question 3, okay, the first part, they're asking you to find the effective resistance, which is the total resistance of the circuit. And please remember that, okay, you have to see that first identify what circuit is this. Okay, alright, this student here uses this particular step, okay, which is wrong because, okay, this is for parallel circuit. To find out the effective resistance or the total resistance of these three resistors of a series circuit, what you need to do is very simple. You just have to add 2 to 4 to 6. So 2 plus 4 plus 6. Okay, and then the answer is actually 12 ohms. Okay, so the total effective resistance of the circuit is actually 12 ohms. Alright, and secondly, find the current flowing through the 4 ohm resistor. Okay, so they're asking you what is the current here. Okay, so as you recall, the current in the circuit is the same whether it flows through 4 ohm, 2 ohm or 6 ohm. So what we are trying to find here is actually the total current flowing through. Okay, so again, part B is linked to part A. Alright, so I'm using back this formula, I equals to V over R. And then the voltage, I know that the total voltage is 6 volts. The total resistance, as we can see, okay, that we have found out in part A is actually 12. Okay, so it's 6 over 12. So the current flowing through the 4 ohm resistor is actually 0.5 ampere. Okay, find the reading of the voltmeter. As you can see, the voltmeter is connected across these two resistors. Okay, so as you can recall, in a series circuit, if I were to actually have an EMF of 6 volts and I'm asked to find this voltage, okay, then the next thing that I must find is, of course, okay, this voltage Y, because if I label this as V1 and this one as V2, then V1 plus V2 must be equals to 6 volts, which is equals to the total EMF. Okay, so the question is, how do I know what's V1? Okay, I can find it, okay, basically by using this formula again. Alright, I can find by using V equals to IR or RI. Okay, so the voltage is total resistance over here, as you can see, is 2 and 4. So V equals to resistance 2 plus 4, which is in a series, times the current, which is 0.5. Okay, so it's 6 times 0.5. So it's actually 3 volts. Okay, so alright, so the voltage across this particular two resistor is actually 3 volts. Okay, so as an add-on, okay, the voltmeter reading for the 6 ohms resistor, it will also be 3 volts because, okay, it is actually the same value for the both, okay, the resistors. Okay, so this is slightly more difficult.